Here we're going to look specifically at what it means to work with absolute value equations. So there's a couple things we need to know or remember about an absolute value. Absolute value is an equation that has the double bars. Okay, so if you remember the double bars, and we would have, say, a variable inside. So this is the absolute value. And what that's telling you is that it doesn't matter what the sign is on the inside of the absolute values, what comes out is positive every time. Okay? So, for example, if I had a negative go in, once I apply the absolute values, you can think of it like you would, say, the walls of a shower. And so once you apply your shower, that negative goes away and leaves you with a positive of whatever that was. Now, at the same result, if I have a positive go in, well, what comes out is going to be the same thing. A positive is going to come out. And so what this means is that when we're dealing with absolute values, we have to deal with both the positive and the negative of our term. Okay? So when we're looking at it, your variable, again, will be inside the absolute value bars. The absolute measures the distance from 0 to a number on the line. So that's kind of what we're talking about. We take the positive and negative into account because of the way the absolute works, in that it comes out being the same result either way. So we've got a couple steps that we have to follow. First, you have to isolate the absolute value to be completely by itself. So what that means is if they have any numbers or operations or anything like that surrounding your absolute value, then before you can evaluate the absolute value, you have to remove that outside stuff. I like to think of it like a candy bar. When you give a candy bar, most people, I would assume, peel open your candy bar before you eat the candy inside. So the absolute value is kind of the same. You have to peel it open before you can actually get to the stuff inside the bars. Now the other piece about it is that after you isolate it, whatever you have on the right hand side of your equation, well, it must be positive. And the reason for that comes back to our definition. The sign does not matter inside your absolute value bars, but it definitely matters outside. And this little positive right here is one of the most important things. This positive that we have, that each of your absolute values equals, think of it like mandatory. Okay? It's fact. So whatever you end up getting on this right hand side, after everything is isolated, this number here must be positive. If it comes out being negative, then your absolute value has no solution. Now once you get the absolute value by itself, you have to break it into two parts. You have to solve the positive part and you have to solve the negative. The easiest way to show that is to work it as an example. So I've got one here that we're going to go ahead and look at. First things first is to always know what your absolute value is. So I've got my absolute value is right here. Okay, so this is my absolute value, or i.e. my candy bar. And here I have two wrappers on the outside. I have this 5 and I have this negative, and both of those have to move to the other side of my equation before I can mess with the stuff inside. Okay, so the first thing I'm going to do is I'm going to take this 5 here and I'm going to move the 5 over to the other side. Since my 5 is positive, to move it says I have to subtract. And I'm going to go ahead and do that, and it's going to leave me with negative absolute value of the 4x plus 3 equals 2 minus 5 is a negative 3. Now don't get ahead of yourself because we still have this negative here. So even though this right hand side is negative, we haven't finished isolating. Okay, so the next thing that we need to do is we need to go ahead and take this negative sign here, and we are going to move that to the other side of the equation. Because it's negative and being multiplied, there's a couple ways that you can think about it. One, you can either think about it as I'm going to divide by -1, or I'm going to multiply the whole thing by -1. Either result is going to give you the answer you want, which is essentially that you're changing your sign over. So this is going to leave us with the absolute value of 4x plus 3, and this is going to equal 3. Now is where we need to look at our sign. Okay, so at this point, since my absolute value is totally by itself, we're going to look at the sign here, and you want to ask, essentially, is this positive? In this case, because we can say yes, then what this means is that we will have solutions. So we have to keep going. Now, because we can keep going, this is where we have to now break it into its two pieces. So for your absolute value, you have two parts. First, you have the positive, so we're going to look at the positive of my 4x plus 3 equals 3, and we're going to look at the negative. Okay, and so we're going to look at the negative of the 4x plus 3 equals 3. And so we have to solve each of these for the x value. Okay, so this now becomes the two pieces that we're doing, and so my solution is going to be containing both. Okay, so let's go ahead and start with 1. So here we're going to have the 4x plus 3 is equal to 3. So this is going to give us that 4x is equal to 0, so x is equal to 0. That is your first solution. Your second one is going to say that we now have the negative of the 4x plus 3 equals 3. So here there's a couple things that you could do with it. You could distribute through, or you could go ahead and divide it out. It's up to you. I'm going to divide it out, so this is going to give me 4x plus 3 equals -3. I'm going to move things over, so I get that 4x is equal to a -6. So x is equal to -6 over 4, which is going to reduce down to a -3 over 2. So in this case, we have two solutions. We have that x is equal to 0 and -3 halves. Alright, let's take a look at another example here. Now, in this example, one of the things that I want to point out is that I have multiple absolute values. So the first thing we want to do is we want to isolate your absolute value. So we're going to look at my operation here, and this operation is negative. So we're going to add this entire absolute value. So this entire piece here, we're going to add to the other side. So we're going to set ourselves up so that we have the absolute value of 6y minus 3 is equal to the absolute value of 5y plus 5. Now, once we do that, we now have to do something a little bit different. And here we have to choose one absolute value to be the absolute value, and then the other one kind of becomes the solution. Okay, so for me, let's go ahead and choose the left-hand side to be my absolute value. So we're going to set this as I have the absolute value of 6y minus 3 is equal to the 5y plus 5. Since it's positive, and my absolute value has been isolated, we're going to apply the absolute value rules. Okay? So in the first example, you could see that we applied the absolute value rules to the stuff under the absolute value. The other place you could have applied it to was the stuff that it equals. You're going to get the same result either way. So here I'm going to show you the other way to do it. So my absolute value stuff would come out, and we would have 6y minus 3 is equal to the positive of the 5y plus 5 and the 6y minus 3 is equal the negative of my 5y plus 5. And now we have to solve them both. So here we get 6y minus 3 equals 5y plus 5. I'm going to take my 5y and move it to the other side. So 6y minus 5y gives me y. I'm going to take my 3 and move it. 5 plus 3 is 8. There's your first one. Here we have to distribute the negative. So I'm going to have 6y minus 3 is equal to a negative 5y minus 5. I'm going to take this 5y and just like before, I'm going to move it. 6 plus 5 is going to give me 11y. Again, I'm going to move the 3. So negative 5 plus 3 is going to give me a negative 2. Get y by itself, and we have that y is equal to negative 2 over 11. So there you have a couple examples, one with a single absolute value, one with a double absolute value, both of which following the exact same identical absolute value rules. So as long as you remember to isolate that absolute value first, and then you have to take both the positive and negative into consideration, you shouldn't have any issues solving your absolute value problems. So if you have any questions, please let me know. If you come across any other problems or you need to see additional examples, let me know that too. I'd be more than happy to work those out. Otherwise, I'll see you next time.